Welcome everyone. We're going to be talking about chemical reactions in this lesson. First slide, you could see that there are 5 pictures here showing evidence that a chemical reaction took place. One of the most common things you'll see is if you see a color change. Let's say something goes from red to blue, or maybe from light blue to dark blue. If there's a color change, usually that's a big sign that a chemical change took place. Another popular one is when you mixed chemicals together and you form a solid which is known as a precipitate. When a solid comes out of solution, you'll see a cloudy substance form. It will settle at the bottom as a solid, which is known as a precipitate. The picture you're seeing here is a white precipitate, but precipitates can come in different colors, such as yellow, blue, aqua, or white, which is one of the more common ones. Another example is when you mix chemicals and all of a sudden you see bubbles or fizzing. This is a sign that a gas has been produced. So whenever there's a formation of a new gas, a sign will be bubbles or fizzing. So that's your third example of an indicator of a chemical change. Now, another one that you might see is the production of light as a result of a chemical change. There are organisms that live in the dark, for instance, in the deep ocean, that through chemical reactions produce light, and that's known as bioluminescence. It's a chemical reaction. Another one is when there's a change in temperature. Now, when there's a change in temperature, that means that you mix some chemicals, and let's say you did this in a test tube, and the test tube got either cold or hot. Either change, whether cold or hot, is a sign that something new was made, that a chemical reaction took place. In fact, if the reaction gets cold, those are usually indicators of an endothermic reaction. And if a reaction releases heat, it will get hot. And those are known as exothermic reactions. So these are 5 very popular signs that a chemical reaction took place. When you look at a chemical equation, you'll notice that on the left side, you have the reactants. The arrow is known as the yields or produces. Do not say equals, because the left side of the arrow is not equal to the right side. They are 2 different things. So it either yields or produces. And what you make on the right side of the arrow are the products. It could be 1 product, 2, or 3 products. The little numbers that you see are known as subscripts. Okay, you could see other examples in the problems that I have here on the bottom. These are subscripts. So for instance, if you have MgCl2, that means there is 1 magnesium and 2 chlorine atoms in that compound. Now, the larger numbers that you see at the front, okay, I'll circle a few here. These are known as coefficients. When we go over how to balance equations, you will see that coefficients are used to balance both sides of the equation so that you have the same number of atoms on the reactant side as you do on the product side. Now, you'll also notice that there are these symbols here. And these symbols, and I'll show you this on the next page, are symbols that represent the state of matter. If you look here, G is the symbol for gas, L for liquid, S is a solid, which is also known as a precipitate. I'll go ahead and write that down. And then you have a very popular one called aqueous. When something is aqueous, it means it's dissolved in water. Let me fix the spelling on that. So it's dissolved in water, and that means that it's soluble. So those are the four that you'll probably be seeing most of the time. Now, take a look at this. We're going to learn how to classify reactions. So I'll talk briefly about each of these, but there's synthesis, decomposition, single and double replacement, and I will mention a fifth one called combustion. So we're actually going to look at 5 different types of reactions. If you look here, we're going to subdivide the 5 reactions into 2 categories. So we're going to go ahead and split it like this. Direct combination is also known as synthesis. Decomposition, single replacement, or combustion, these 4 that you see on the left here, fall under a category called oxidation-reduction reactions. Now, I will go over what that means, but these 4 types of reactions all fall under that category. And then for double replacement, which is the 5th category, there are 3 types. There's one called a precipitation reaction, another one called an acid-base, and a third one called gas evolution reactions. Now, there is something very important. In order for a chemical reaction to take place, there are what we call 4 driving forces. And what I mean by driving forces, these are events that need to take place so that a chemical reaction will proceed. The first driving force is that there has to be the formation of a solid. And that is basically what a precipitation reaction is. A precipitation reaction, what drives that reaction is that you form a solid. The second one is called formation of a liquid. Now, the liquid in most of them is usually water. And that honor goes to acid-base reactions. You see, when you have an acid-base reaction, what happens is an acid will react with a base. It's a type of double replacement, and you'll make salt and water. And the liquid here, the water, is actually what drives the reaction, the fact that you're making water. The third driving force is called formation of a gas. And that, you can tell, goes to number 3 here. Gas evolution reactions are reactions in which a gas is produced, and that's what drives the reaction. Now, these 3 driving forces out of the 4 all drive double replacement reactions. There is a 4th driving force, and that's responsible for driving the 4 that you see on the left-hand column. So the 4th one is called a transfer of electrons. So when there's a synthesis, a decomposition, a single replacement, or a combustion, what drives those reactions is that electrons are transferred. See, that does not take place with double replacements. That's why double replacements are in their own separate category. So what drives the synthesis, decomposition, single replacement, and combustion has to do with a transfer of electrons. And we call those oxidation-reduction reactions. So I'm going to elaborate a little bit more on what an oxidation-reduction reaction is. We have an acronym that I use called OIL-RIG. This will help you remember what oxidation and reduction, what those words mean. You see, oxidation, if you look at the word oil, which I highlighted here, oxidation involves losing electrons. So when something gets oxidized, that means that it loses electrons. Those electrons that are lost will get transferred, and there'll be someone else gaining those electrons, and whoever is gaining the electrons is going to undergo reduction or is going to get reduced. So when something undergoes reduction or gets reduced, if you look at the acronym here, RIG, reduction involves gaining electrons. So there's an exchange of electrons. Somebody loses, somebody gains. The one that loses gets oxidized. The one that gains gets reduced. There's a result here of a transfer of electrons. And the transfer of electrons is known as oxidation reduction. Okay? So who does this? Well, synthesis, decomposition, single replacement, and combustion. Double replacement do not undergo transfers of electrons or oxidation reduction reactions. So here, if we break this down again, these three here are your double replacements. Some textbooks call it displacement. Same thing. So it's either double replacement or displacement. You can use either term. What drives a precipitation reaction is the formation of a solid. An acid-base reaction is driven by the formation of a liquid, which is basically water. And a gas evolution is driven by the formation of a gas. Now, under oxidation reduction, this is driven by a transfer of electrons. Now, combustion is written underneath, but remember that there's three others. Synthesis also is an oxidation reduction. So is decomposition. And single replacement or displacement. So for oxidation reduction, you have those five. All right, so here's a brief summary. In a synthesis, also known as combination, notice that the reactants are combining and forming one product. So there's only one product. Everything comes together. If you flip a combination reaction, the opposite is called a decomposition. So notice that in a decomposition, there's only one reactant, and what it does is it breaks apart into two or more products. So synthesis and decomposition are exact opposites of one another. In a synthesis, you're putting something together, and a decomposition, you're breaking them apart. Now, take a look at a single displacement. One way that I like describing this, think of a couple dancing. You got a boy here and a girl. And let's say that this boy wants to cut into the dance. So the boy wants to get together and dance with the girl. And then the other boy gets displaced or is asked to step away. So notice how A, this boy here, and C get together. And notice how B got displaced, it got kicked out. So whenever you have, and you can think of this analogy, if you have a couple dancing and somebody cuts in, that's called a single displacement. Okay? Notice you have your new couple dancing, and here's the one that got displaced or kicked out. In a double displacement, remember another word is replacement, you have two couples dancing. Now, what happens here is the couples are going to switch partners. So think of this as a boy, girl, girl. I always compare this to math. In math, there's this acronym called FOIL, where we put the outers together. So notice that A and D get together, this boy and this girl get together and form this new couple. And then notice in foil, the outers get together and the inners get together. Notice that B and C get together. Now, we'll talk about why C is written before B. Okay, but when B and C get together, C is written before B. We'll talk about that. That has to do with metals and nonmetals. The metals always go first. The metals are the positive ions. So A and C are the metals. They're positive. Whereas B and D are the nonmetals. They're the negative ions. And that is the reason why A and C go first, because the metals go before the nonmetals. Okay, but notice in a double displacement, basically it's two couples dancing and they switch partners and you get AD plus CB. All right. Here's a summary of all of them. The only one I'm going to elaborate a little bit more on is combustion. Combustion, one of the things that all combustions have in common is that you're burning something in the presence of oxygen. So let's take a look at the first example. A metal and oxygen. Let's say you had magnesium reacting with oxygen to form MgO. I'm going to go ahead and balance this for now. You got to put a 2 here and a 2 here. This is an example of a metal and oxygen combining. Now, if you said, but wait a minute, that looks like a synthesis. You're right. This reaction actually can be classified one of two ways. You can classify this as a synthesis because you do have only one product. Notice they got together. But because oxygen is a reactant, and this is the key with combustions, if you see oxygen in its elemental form, which is diatomic, if you see it as a reactant, you can also classify it as a combustion. So this can be classified in one of two ways or both. Now look at the next one, a nonmetal and oxygen. Same thing. Here's a nonmetal. Here's oxygen. This is a really popular one. You can form sulfur dioxide gas here. Sometimes you can even make sulfur trioxide. I'll leave it at sulfur dioxide. It's already balanced. The only difference is that this time it's a nonmetal and oxygen. But again, look at this carefully. This can also be classified as a synthesis because you only have one product. The combustions that you're more accustomed to seeing is a compound with oxygen. I'm going to give you 3 of the most common ones. You can have a hydrocarbon, we'll call it X and Y here. Any hydrocarbon plus oxygen will yield carbon dioxide and water. And that hydrocarbon is the compound. This is your more classic type of combustion. You're burning a hydrocarbon in the presence of oxygen, and the result is carbon dioxide and water. You could also be burning a sugar, so we can call it X, Y, and Z. Sugars are usually 1 to 2 to 1 ratios of CH to O, but it's the same idea. You're burning it in oxygen, you still make CO2 and water. Sometimes you might be burning an alcohol, so it might look like this, X, Y. Alcohols have an OH here at the end, so this would be an alcohol. And same concept, you're burning it in the presence of oxygen and you're making CO2 and water. Notice what all combustions have in common. They all have oxygen as a reactant, and that's a key. Okay? Now, quick recap. Remember that synthesis, combustion, okay, decomposition, which is the opposite of a synthesis, and single replacement. Remember these first 4, they're all oxidation-reduction reactions. What drives them is that there's a transfer of electrons. In a double replacement, we can break it down into three categories. We have precipitation reactions, acid-base reactions, also known as neutralization reactions, and then you have gas evolution reactions. And double replacements are driven by either the formation of a solid, a liquid, or a gas. Obviously, if a solid is made, we call those precipitation reactions. Usually, if water is made, that's usually the liquid. Those are your acid-base reactions. And if one of the products is a gas, we call those evolution of a gas or gas evolution reactions. So those would be your three types of double replacement or displacement reactions. Okay? So those are the five reactions that we're going to focus on. We will have videos that elaborate on each type more specifically. This is a more general review of the 5 types of reactions.